Have you ever observed the shape of the globe? You will notice that it bulges in the middle and is slightly flattened at either end, just like the Earth. The Earth also bulges at the equator and is slightly flattened in the polar regions. So, now, can you tell me what a globe is? That's right. A globe is a tiny and realistic replica of the Earth. Globes come in a range of shapes and sizes, including large ones that are difficult to transport, small pocket globes, and globe-like balloons that can be inflated and carried easily. The globe can easily be spun as it is not fixed in its position, similar to how a topspin rotates. Countries, continents, and oceans are represented in their right proportion on the globe. Did you notice that the globe is fixed in a tilted position with the help of a needle? This needle acts as the axis of the globe. The axis runs through the North Pole and South Pole, 2 points on the globe. With the help of the axis or the needle, the globe can easily rotate in one direction, just like the Earth. Can you guess the direction? Yes, that's right. The globe rotates from west to east. But does this mean that the Earth also has an axis? No. The Earth rotates around an imaginary and not a real axis. Can you think of another imaginary line that divides the Earth into equal halves? Yes, that's right. The equator divides the Earth into the northern hemisphere in the top half and the southern hemisphere in the bottom half. Now, if we want to find the location of a place on Earth, how do we find it? The equator is a vital reference point for determining locations on the globe. However, we cannot determine locations with just the equator as a reference point. We have divided the globe into 180 slices, 90 slices north of the equator, and 90 slices south of it, each slice parallel to the equator. These slices are parallel circles that grow smaller in size the further they are from the equator. The axis runs through the center of each circle. These circles are measured in degrees and are called parallels or lines of latitudes. The equator is numbered as the 0 degrees latitude. Can you guess the degrees of the poles? Because the distance between the equator and either pole is 1/4 of a circle around the planet. It will be 1/4 of 360 degrees or 90 degrees. Thus, the North Pole is located at 90 degrees north latitude, while the South Pole is located at 90 degrees south latitude. As a result, all parallels extending north of the equator are known as north latitudes. All parallels south of the equator are known as south latitudes. Thus, the value of each latitude is accompanied by either the word north or south. The letter N or S is usually used to signify this. These parallels of latitudes also act as reference points for determining locations. Let us look at an example to understand this well. Chandrapur in Maharashtra, India, and Belo Horizonte, Brazil is on parallels of about 20 degrees latitude. However, the former is 20 degrees north of the equator, whereas the latter is 20 degrees south. As a result, we can state that Chandrapur lies at 20-degree north latitude, while Belo Horizonte is at 20-degree south latitude. Let's recapitulate what we have learned. Have you ever observed the shape of the Can you recall the name of the important imaginary line that divides the Earth into equal halves? Yes, it's the equator, which lies at 0 degree and is the longest parallel of latitude. Can you also remember the latitudes that lie at 90 degree north and 90 degree south? Yes, it is the North Pole and the South Pole respectively. Are these the only important parallels of latitude? No. There are 4 more. Let us take a quick look at them. We have the Tropic of Cancer, which lies at 23 degree 24 minutes north, and the Tropic of Capricorn, which lies at 23 degree 24 minutes south. Together, these are called the tropics. Then we have the Arctic Circle located at 66 degree 33 minutes north, and the Antarctic Circle located at 66 degree 33 minutes south. Together, these are called the polar circles. Why do we call these latitudes significant? We already know that they help us in determining locations. Have you ever wondered why some places are cold all year round, like in Russia, while other places are always hot, like the Thar Desert? These latitudes are also important as they divide the Earth into different climate zones based on the amount of sunlight received by each zone. Let us look at the globe. Can you guess what the different colors signify? The different colors represent the average temperature experienced in that zone. Next to the equator, temperatures can range from 23 degrees Celsius to 31 degrees Celsius. While at the poles, they range from minus 28.2 degrees Celsius to 0 degrees Celsius. Let us explore these zones further. Earth can be divided into 3 heat zones based on the climate. These are the torrid zone, the temperate zones, and the polar zones. The midday sun shines directly overhead at least once a year on all latitudes between the tropics of Cancer and Capricorn. Due to its extreme heat and sunlight, this region is known as the torrid zone near the tropics. Can you guess what the climate in this zone will be like? It will be extremely humid and warm with lots of rainfall. We can also find most of the deserts here. The temperate zone falls between the tropics and the polar circles. We generally experience all the 4 seasons throughout the year. The 2 temperate zones in the northern and southern hemispheres are the largest of the heat zones. The sun does not directly shine on this zone, so the weather is moderate. There are 2 polar zones, which are the regions between the North Pole and the Arctic Circle in the northern hemisphere, and the South Pole and the Antarctic Circle in the southern hemisphere. It is cold throughout the year, as the sun rays are always slanting and rarely fall above the horizon. But why do the sun's rays play such an important role in affecting the climate? Remember, the Earth is spherical. This means that the regions next to the equator get more direct sunlight, which is concentrated over smaller areas. This is because the rays have to travel a shorter distance and thus can heat the Earth more. As we travel away from the equator, the shape of the Earth causes the rays to strike its surface at an angle and travel longer distances. These slanting rays cover a larger area and thus are unable to heat to the same extent. Now let's recapitulate what we have learned. We have already learned how latitudes help us in determining locations. However, do you think latitudes are sufficient to help us locate places? They only help us in finding out locations north and south of the equator. How would we find out the precise location of a place? For example, the Pacific Ocean's Tonga Islands and the Indian Ocean's Mauritius Islands share the same latitude, that is 20 degrees south. To properly locate them, we must first determine how far east or west they are from the prime meridian. Longitudes help us in determining the location of a place on Earth, east or west of the prime meridian. Longitude lines are also called meridians. They are the imaginary lines that run from the North Pole to the South Pole. Each degree of longitude is further subdivided into 60 minutes, each minute into 60 seconds. The shape of the longitudes is semicircle. The widest areas of longitude, measuring 111.32 kilometers, are near to the equator, where the Earth bulges out. Longitudes reduce to 0 kilometer at the poles. All meridians of longitudes meet at the north and south poles. But what do we mean when we say the prime meridian? As longitudes are of the same length, being half of a great circle on the Earth's surface, it is tough to count them. Each longitude measures 20,003.93 kilometers in length. As a result, all the countries agreed that the count should begin from the prime meridian, which runs through the Royal Observatory located at Greenwich. Greenwich. The prime meridian passes through the United Kingdom, France, Spain, Algeria, Mali, Burkina Faso, Togo, Ghana, and Antarctica to the South Pole. The prime meridian has a value of 0° longitude. We can count 180° eastwards and 180° westwards from it. Just like the equator, the international dateline and the prime meridian divide the Earth into two halves, named the Eastern Hemisphere and the Western Hemisphere. Except for the prime meridian and the international dateline, the suffix E or W appears after the number given for the longitude. For example, 80° east, the line passing through Chennai, India, is located at an angular distance of 80° east of the prime meridian. 80° west, which passes through Pittsburgh of Pennsylvania in the United States, is located at an angular distance of 80° west of the prime meridian. Now, let's recapitulate what we have learned. How do we measure time? We know it is morning when the sun rises, afternoon when it is at its peak position in the sky, and night when it sets. This way of telling time is universal, as the sun sets and rises every day over the world. Did you know that our shadow is the shortest at midday and longest at sunrise and sunset? The Earth rotates 360° from west to east in 24 hours. The time taken by the Earth to complete one rotation and pass between the two peak positions of the Sun is called a day. Thus, if we divide 360 by 24, we get 15, which means that the Earth takes 1 hour to cover 15 degrees. So, how much difference in time would 1 degree of longitude cause? Let us divide 60 by 15, which gives us 4. Thus, each degree gives us the difference of 4 minutes. We have learned that there are 180 longitudes, both to the east and west of the prime meridian at Greenwich. The prime meridian is used as a reference point to determine time on other longitudes. As we travel east of the prime meridian, the time increases, and as we travel west, it reduces. As we saw, time is either added or subtracted with each degree of longitude. Most countries have multiple longitudes running through them. Adjusting our watches every time we travel would be difficult, which is why it was decided to use a standard time within a country by taking the local time of a standard meridian within the country. Can you guess the standard meridian of India? It is 82.5° east. The time at this longitude is known as the Indian Standard Time or IST. As some countries are vast in area, they have more than one standard meridian, which means a corresponding number of time zones. Can you think of any such countries? Russia has 11 time zones and the USA has 6. Let us do a simple time sum. There will be a cricket match in London at 2 p.m. If you and your friends want to watch the match screening on television in India, what time would you set your alarm? We already know that London is at 0 degree of longitude and India lies 82.5 degree east of it. 1 degree of longitude makes a difference of 4 minutes. That means 82 degrees of longitude multiplied by 4 would result in 328 minutes. Half a degree would result in a difference of 2 minutes. So 328 plus 2 brings the total to 330 minutes, which divided by 60 is 5.5 hours. As time increases on moving eastwards, we add 5.5 hours to 2 p.m. in London. We would have to set our alarms for 7:30 p.m. in India. We have already seen how the prime meridian helps us in calculating the time. What about the international dateline? It is the place where the day truly starts and lies at 180 degree of longitude, regardless of traveling eastwards or westwards from the prime meridian. The time at the international dateline would be 12 hours from it. Thus, it would take us 12 hours to travel from 0 degree to 180 degree. After crossing the international dateline, a person traveling eastward on Tuesday will count the day as Monday. When traveling westward and crossing the international dateline, the trip begins on Sunday and ends on Monday. Let's recapitulate what we have learned.